First question in design and analysis of algorithm. What is algorithm? Define the role of algorithm in computing. Input goes to algorithm, gives output. For solving any problem, there may be one or more methods. We can formulate some step-by-step actions to get the solution of the problem. These steps are nothing but an algorithm. Role of algorithm in computing. Role of algorithm in computing. Any software depends on two things: the algorithm chosen and efficiency of various layers of implementation. Good algorithm design is crucial for the purpose for all software systems. Study of algorithm provides insight into the intrinsic nature of the problem as well as possible solution techniques, independent of programming language. It introduces formal techniques to support the design and analysis of algorithm. The algorithm is a set of rules which are used to solve real-life problems. Explain different means of improving efficiency of algorithm. How to increase the efficiency of algorithm? Removing redundant computations outside loop, refreshing of array element, inefficiency due to late termination, early detection of designed output conditions. When more tests are carried out than the required to solve the problem leads to late termination. In some case, for example, bubble sort algorithm establishes the desired output condition before general condition for termination is met. The efficient design of the algorithm can reduce a significant amount of memory access. Next question, explain characteristics of good algorithm. List the problems. List the problems solved by the algorithm and define efficiency. Good characteristics of algorithm are definedness. Algorithm must be clear, effectiveness, precision. The steps are precisely stated, defined. Uniqueness. The results of each step are uniquely defined and only depend on the input and the result of the preceding steps. Finiteness. The algorithm stops after a finite number of instructions are executed. Input. The algorithm receives input. Output, one or more output. Problem solved by algorithm: sequential search, bubble sort, 10 pins problem, 15 puzzle problem, merge sort, quick sort, job scheduling problem, fractional knapsack problem, closest pair problem, single source shortest path problem, Huffman code generation problem, graph coloring problem, Hamilton cycle problem, traveling salesperson problem, geometric and numerical problems. What do you mean by efficiency of algorithm? Amount of resources used by an algorithm. Space, number of variables, time, number of instructions. When design algorithm must be aware of its use of resources. How to confirm the correctness of algorithm? Explain with example. Correctness of functional algorithm. The principle of mathematical induction. It states that for a given statement which involves a natural number n, if you can, first point basis, show that the statement is true for n is equal to n0. Induction hypothesis. Second point. Assume that the statement is true for n is equal to k, where k is greater than equal to n naught. Induction step. Show that statement is true for n is equal to k plus 1. Then the statement is true for all natural numbers. N is greater than equal to n naught. Next, discuss about examples. Examples of correctness of algorithm. Analyze the correctness of functional algorithm is to compute a raised to n. Using mathematical induction, a raised to n is of type power p into n gives n. Can be written as power of a comma n. Answer is 1 if n is equal to 0. Otherwise, a into power of a comma n minus 1. Let us apply of mathematical induction for n is equal to 0. Power of a comma 0 a raised to 0 is equal to 1. Induction hypothesis. Assume the statement true for n is equal to, that is power of a comma k is equal to a raised to k for n is greater than equal to 0. Induction step, we have to prove that the statement is true for n is equal to k plus 1. Power of a comma k plus 1, a into power of a into k. By definition, power of a comma k is a raised to k, a into a raised to k. By induction hypothesis, a raised to k plus 1. Hence, the statement is true for all n is greater than equal to 0. Write a short note on evolution of algorithm. In 21st century clear English philosopher cleared CLEARD. English philosopher cleared Debach used the term algorithm in 1800s. George Boole established Boolean algebra. In 1847, Boole unified logic with calculation and formed binary algebra. In 1943, Stephen Klein's established algorithm theory, which is complete algorithm theory. Klein's theory set up the rule that algorithms of today follow independent self-sustaining computational functions that would execute operations within a finite set of instructions. Next. How can you measure and increase the efficiency of algorithm? How can you increase the efficiency of algorithm? The efficiency of algorithm, first definition of efficiency of algorithm. The efficiency of algorithm is defined as the number of computational resources used by the algorithm. For maximum efficiency of algorithm, we use to minimize resource usage. Time and space complexity are considered as logarithm algorithm efficiency. Loop decide depth of iteration and nested loops in loop within loop. Hence, it plays an important role in efficiency of algorithm. Removing redundant computations outside loop, removing redundant operations, refreshing of array element, inefficiency due to late termination, early detection of design output conditions. The efficiency of algorithm can be measured by using time and space complexity. Total time of algorithm is measured as T of n is equal to 1 of initialization plus n of comparison plus increment addition plus assignment. The study of algorithm efficiency focuses on loops. Functions containing loops vary widely in their efficiency. Efficiency analysis of algorithm depends on order of complexity in terms of input size n. Next, explain the issues. This is important question. Issues related to iterative algorithm design. Iterations using the loop control structure, improving the efficiency of the algorithm. Estimation of time and space requirements. Expressing the complexities using order notations. Applying different algorithm strategies for using loops. Initial condition is said to be true before beginning of loop. Invariant relation, which must told before and after each iteration of loop. Termination condition, under which loop ends or terminates. Next, example based on iterative design issues. I is equal to 1 initial condition, while I is less than equal to n. Terminating condition, sum is equal to sum plus I. Invariant relation, I is equal to I plus 1. Correct use of loops in the program factors that affect the efficiency of algorithm. Estimation and specification of execution time and order notations. Difference between, this is also important, definedness of algorithm and effectiveness of algorithm. It is defined as the precision maintained in each step clearly to avoid any kind of ambiguity. It ensures that each step of the algorithm should be executed in a finite time. X equal to 1 in this instruction, the value of x remains constant. Thus it shows definiteness. X is equal to 1 upon y plus 1 upon z. In this interaction, value of x can be determined in a finite time. Thus it shows effectiveness. The algorithm must always terminate after some finite number of states. The algorithm must be sufficiently basic that they can be done exactly as per specification. The algorithm steps must have definite length. The algorithm steps must have finite length. Types of complexity classes, 2 marks question, P class, NP class, UNP class, NP hard, NP complete. Taxonomy of complexity classes, problems are P class and NP class problems. In NP class problems divided into two parts, NP complete and NP hard. Thank you.